Hello everybody, welcome to my class, that is the maths experiment class. So today I am going to demonstrate about how to find the volume of pyramid and also its lateral surface area and total surface area, just not by applying the formula but experimental. And we will also see that how to develop the formula to calculate this sort of dimensions by using the experimentation method. So in this regard, in order to do some experiment, we have to make pyramid. So you take a paper like this, chart paper, or if possible you can also take some cardboard of a reasonable size, and then you suppose that this whole thing is the chart paper, and on this chart paper you can make a square. So I am going to make a square base pyramid. So make a square of length I have made here 15 centimeter, but you can fix the size as you feel it is appropriate. Okay. So in that case, this side length of the square is 50 centimeter, and I have taken this perpendicular length as 30 centimeter here, and by the reference of this midpoint, I have just used the pencil and then I draw this triangle, this triangle, this triangle, and then 4 triangles of equal area. That is, all those 4 triangles should be the congruent triangle. So after that, once you have drawn the figure on this chart paper or the paper's cardboard paper, and then once your framework is ready, apply a scissor, okay, or a cutter to just cut this side gently, so that you should not lose the dimension of size of the triangle or the size of this figure. So once you cut this side, you cut this side, this side, this side, then you have figure like this. Alright, so you will have figure like this. Now once you fold about the sides of the square that you have drawn, then you can see this is now a pyramid. It's okay? This is a kind of pyramid, and hence now we should be able to calculate the total surface area, lateral surface area, as well as the volume of this pyramid. So in this case, first of all, if I talk about to find the lateral surface area, in the lateral surface area, what you can see actually, these are the slant triangles. Look at here now. So this is a triangle. I have taken four isosceles triangles. In this case, if you drop a perpendicular like this, if you drop a line pass through the middle of this side, then it will be perpendicular over here. Okay. And then you can apply the formula to calculate formula of area of triangle as half base into height, and then you will get the area of this triangle. Yes, and similarly, as all the triangles are congruent, so we have 4 times of area of this triangle will give you the entire area of the all 4 triangles. That means if you are calculating area of all 4 triangles, and then this will be called the lateral surface area. So in this object, what I have taken here, that you have for each triangle, you know that area of a triangle is half base into height. Okay, but I have taken the 4 congruent triangles. So what you can write here, the total area of the triangle as the lateral surface area of the triangle. So 4 times of that. So 4 times of 1 by 2, and base means base is the side of the square where this triangle stands. It's okay. So this length is 15, that is the base of this triangle. So I write here 15 times, and the height is how much it is? 30. Okay. So times it is 13, and units are, I have taken in centimeter length. These lengths are in the centimeters. So what is the height? A square centimeter. Now after you calculate this value is going to be 2 times of 15 is 30, and then this is 13 equal to 13 3 39 and 1 0 is here. So you have here 390 square centimeter as lateral surface area. That means what we have taken actually, we have not taken the area of the base at this time. So I have taken only the area of this sort of triangles which are making the lateral part of this figure. So calculating area of all triangles give you the lateral surface area for this pyramid. Okay, and otherwise in the formula area you just observe the nature of the triangle. If it is isosceles triangle, you can apply the formula for the isosceles triangle to calculate its area, and if this is equilateral triangle, then you can apply the formula to calculate the area of the equilateral triangle. And now we are talking about total surface area. That means we talk about only the upper area of this figure, this model. Now total surface area means it includes base also, and you can see the base is a square here, and length is, I have taken here 15 centimeter. So area of a square is 15 square. That means in the total surface area, what you do, LSA, that is lateral surface area, and plus area of the base in this case, area of the base in this case. So lateral surface area we have already calculated 390. Okay, and then plus area of base means its length is 15 and its breadth is also 15, or you can write 50 square over here, so that it is 319, and 15 times 15 it is 225. So okay, otherwise you can use the calculator to calculate this. And now it is 5, this is 11, and 3 plus 2 5 and 1 6, and then this is a square centimeter. So this way you can calculate the total surface area, and also you can describe such sort of activity in by making a model like this. Next we talk about how to find the volume of a pyramid. Now look at here. Although we have taken the symmetric figures for the triangle, and in the base I have taken here the squared base, but in order to find the volume, if you are taking length and breadth, it's okay, the area of the base, but in the height the things are not perpendicular to the base here, it is slant to the base. That means it doesn't have some material outside in the gap between this base length and between this triangle. So therefore we have to go through some alternative way to find the volume of a pyramid. So let's check. You require 6 pyramids in this case. So let me add here, like it's the same kind of pyramid, only the dimension is different over here. So let me join these 2 pyramids, and now can you bring? Yes. You have another 2 pyramids. Yes, fix in here from outside and this. Sorry. Yeah. Just a moment. Look at here now. So at this time, I have combined all these 4 pyramids only. So what you can see here, that as if it is forming a kind of box. Yes, and if you consider the pyramid having the square base, so this length and this length and the length in this figure of this side, they are the same. It's okay. But what about the height of the pyramid here? So you can check here that this is the length of the square. Yes, and in a single length of a square there are 2 pyramids. That means length of, or the side length of the square is the double of the height of the pyramid, or height of the pyramid is the half of the length of this side of the cube. So what you can write in this case is that, first of all, so length of the pyramid. In this case, you can call this as L. Length of pyramid is actually half the length of the side of the cube formed. Or if you are taking only one face, you can call this face as a square. It's okay? And that means if you suppose length of the side of the cube formed by combining all 6 pyramids as L, then length of the pyramid in fact is going to be half of the L, that is L by 2. So let's complete the figure now. Okay, this way and then another, yeah, this way. Look at here now. I mixed up all 6 pyramids together to form a, can you bring it? Yes, up here, down to here. So if you mix them up, this is now a box, cubical box. Cubical box means its length, breadth and height, everything is equal. All sides are equal over here, all dimensions. So in that case, what you can write here, as you have assembled 6 pyramids to form a single cube, that means what you can say actually, volume of this 6 pyramid is equal to the volume of this cube. So this way, what you can write here, volume of the six pyramids equals to volume of the cube formed. So I have written here volume of the 6 pyramids equals to volume of the cube formed. So why I use this word formed? Because this cube has been formed by taking the 6 pyramids. So this is 6. Okay? That means you can say 6 times of volume of the pyramid, if you call this as V, equals to volume of the cube having length which we are suppose this is L, so this is in fact L. Yes? So therefore V equals to, you can write here, LQ by 6. That means volume of each pyramid will be 6 times less than the volume of the cube which was formed by taking or combining 6 pyramids together. So now just readjust it now. So let me write here 1 by 3 and then time it is L square and then time it is L by 2. So let's check it mathematically first, that it is 6, so I can write 3 times of 6. Then L cube can be written as L square times L. But what I have written is, there is a reason behind it, that look at here. So in this pyramid, if you form the cube, height of the pyramid will be the half the length of the side of the cube. Alright? So in that case, in fact this is height of the pyramid. Alright? Pyramid. And L square if you talk, so this side length is L for example, or you can suppose here also the length of each side in the square is L. Alright? So L square means it is L times of L. That is the area of this base. So what you can write here? This is 1 by 3. This is area of the base. Whose base now? Before it was cube's face. Now it is the base of the pyramid. So L times L is L square. So this L square is in fact area of the base. and L by 2 is the height of the pyramid. It's okay. So therefore we can say that volume of pyramid, yes, in general of pyramid, volume of a pyramid is in fact 1 by 3 area of base times height of the pyramid. And if you calculate all these values, your answer you have to express in cubic centimeter. It's okay. So in this pyramid, you can use the dimension to find the volume. That means each length is 15. So you can write area is 15 times 15. So in this case, what you can write here, volume equal to, just write here now, V equals to 1 by 3, and as its side length is 15 and 15, so its area of the base will be 15 square. So times it is 15 square, and times height, you can see here, half of the length of the cube it was from, whose length was L, that was what it is here, half of this side. It is 15, so length will be now 7 by 2, 15 by 2. So its length is now 15 by 2. Now calculate this value, and the answer that you will get here is in cubic centimeter. So this way we can demonstrate the area and volume of a pyramid. Okay guys, hope the experiment was fruitful in order to see the work that we do through by using formula. Here we have visualized the things by experiment. Thank you so much.